Okay, so the next talk is a good friend of mine, and he's going to be talking about containers and serverless and other buzzwords.
That's right. Exactly. Any questions?
A round of applause. A round of applause for him, please.
Thank you. Thank you. All right. Since I'm a bit behind, I will skip that first slide. Doesn't really matter. I'm a developer advocate hanging out at conference parties and bitching about other products, so that's fine. And blah, blah, blah. All right. So what I want to do with this talk is imagine you have a monolith written in Go. Boss comes around, she tells you, modernize it, make it cloud native. And you go like, all right. So we have two options, very popular ones, containerized microservices on the one hand, on the other hand, serverless, Lambda. So the monolith is really very, very simple. It's called Imagine. You can upload some images, and it extracts some metadata. Very simple, and I'm not going to go into detail here. I'm going to jump into the first option, and that is containerized microservices. And now there will be a live demo, which means I'm going to put away the mic for a moment. If you want to follow along, you can go to that GitHub repo and try it out yourself if you have a Kubernetes cluster running around.
I can hold it. That's my job.
All right. It's just a couple of commands, bringing up the storage and bringing up the app. Brilliant, wow. And exposing that front end. So, just want to give you a little bit of a feeling how that actually looks like. And now we should see, if all the pods are up, we should see that front end up here. Okay, cool. Yeah, now we can upload something, blah, 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 blah. And at some point in time, the metadata extraction will kick in, which is just a dimension here. And yeah, we're not going to wait for that. Yeah, okay. So this is how it looks like, how it's supposed to work. Now, thank you. Let's have a look at how it is done. First, we'll step back a bit and have a look at what is the underlying platform, and that is Kubernetes. Kubernetes is a container lifecycle management system using declarative APIs and control loops, and super extensible. A lot of moving parts there. As a developer, you typically don't really have to deal with all these interfaces and so on. You can really focus on developing the application. However, if we look at that, we end up from that monolith with a couple of microservices. One that is essentially serving the static assets, so the UI, CSS, and so on, and exposing the HTTP API, allowing you to upload an image and to list the images and the metadata, and the other one is a batch metadata extraction. And again, the metadata is really just the dimensions here. And then I'm using Minio, which is essentially an S3 clone, to store the images and the metadata. It essentially, this containerized microservices setup just leverages vanilla Kubernetes abstractions, deployment services, and so on. And that's how it actually looks like. So you've got these three deployments there with the pods there, everything stateless. The state is essentially in Minio. And then you have the endpoints there. And you've just seen how it is deployed. It's pretty straightforward. The trick is a little bit how do you map or how do you extract, how do you break down that monolith into one or more deployments there. Alternative system designs, I could have just done a lift and shift, essentially taking that monolith and put that into a pod. I could also have the different containers in one pod and use a local volume to share the images and the metadata. Or I could have different pods and using a persistent volume rather than Minio. Minio, in that case, is a little bit more flexible because I'm not dependent on the environment where I am to see what kind of read-write volumes I have available. All right, let's move on to serverless. Here, the demo is luckily a video because it takes a little longer. Okay, so there's a make file. I don't think you can really see that very well. Essentially using SAM, so the serverless application model CLI, which under the hood is just CloudFormation. You have a couple of buckets there where you have the images, the code, and so on. And then it deploys that, taking too many minutes. We're not going to wait for that until it's there. And yeah, you see the stack coming up. And at some point in time, the Lambda functions are there. All the code is ready. The API gateway, so that you can hit the functions there. And yeah, at the end of the day, all that is needed is essentially in the last step to wire the front end, which is statically served from an S3 bucket, to the UI so that the front end actually has the correct HTTP endpoints. Yeah. Okay. End results should be the same. Obviously, yeah, you've got CloudWatch for the logs. Not so super interesting, but essentially more or less besides the provisioning, more or less the same steps. All right. So, what is serverless? Serverless is really just an umbrella term for a couple of things like functions as a service. There are databases and data stores, object storage, message queues, query services, and all of that essentially means you don't have to provision anything. You're only paying for what you're actually using. So you're not paying all the time when it's running, just for what you're actually consuming. Typically, everything is nicely managed there. There are nice APIs there. It's really kind of this operation model where you can focus on your business logic and leave the whole operational part to some provider. So function as a service, that's the service concept that I've been using here to implement that Imagine application, is essentially event-driven. So you have some kind of events that could be a HTTP call through the API gateway. It could be a new image is uploaded into an S3 bucket or whatever. You have one or more short-running stateless functions. And because they're stateless, it means you have to externalize the state. You need to put that somewhere. It could be, a relation database. It could be an NoSQL database, message queue, whatever. So how does it look like? Serverless. We've got 3 Lambda functions. One for uploading the image, one for listing the images and the metadata along with it, and one that does the metadata extraction, again, just the dimension. And using S3 as the shared storage for the images and the metadata, and serving the static assets for the UI. And as you have seen, using SAM to deploy the Lambda functions. If you're using SAM or something else, doesn't matter, but don't use the low-level stuff. Don't use the manually doing the deployments of Lambda functions and so on. You will have a bad day. And if you look at the Git commit history, you will see how much pain I went through. So that is how it looks like. You have the buckets there and the Lambda functions and the HTTP API gateway that triggers the respective functions there. And the metadata extraction is essentially triggered by a CloudWatch event every, I think, 1 minute or whatever, looks into that bucket and sees if there is a new image, extracting that and putting the metadata back then. All right. Alternatively, I could have used a trigger on that bucket where the image is uploaded to trigger that metadata extraction rather than using periodically a CloudWatch event. And I could have replaced the two-phase pre-signed URL that I have there to allow someone to upload something with something like Kubernetes, for example. There are definitely other options as well. These two came to mind. All right, have a look at comparison. How do they compare? Actually, they're quite similar. In certain things, they're different. But if you look, you have unit of deployments, part in the function. You have some artifacts you need to put somewhere. So container image in the case of Kubernetes, a zip file in case of Lambda. Put them into registry, into a three bucket. The biggest difference there in terms of event triggers is that Kubernetes it's not entirely true with Knative now, but vanilla Kubernetes doesn't really have this notion of events that you can use there in Lambda, or in pretty much all the public cloud offerings that offer some functions as a service. They are built in. State, you can have stateful sets and other things, custom resources. In case of Lambda, it's stateless, right? There is no state in that function. Latency-wise, can be sometimes challenging. Get back to that in a moment. Observability, obviously, you're a bit more locked into if you're using a cloud provider there. The main point, as I already mentioned, with serverless, you only really pay what you consume, and essentially, with all the stuff that I've been doing there, my bill was never more than 1 cent. That's pretty much it. The main point in terms of lift and shift, you can do that with Kubernetes. You can take an existing application, just put it in a container and run it. I'm not saying that's the best option, but you can. With serverless, you can't. You really need to re-architect. And local development, it's doable in Kubernetes. There are a couple of things that allow you to do it less painful, scaffold and many other things. With Lambda, it's limited. You can essentially only use gateway and the Lambda itself. So anything, any other, like the S3, whatever, I would need to go into live. It doesn't allow me to emulate that locally. So what's the good? In terms of Kubernetes, definitely provides portability. You can start on premises, move to cloud, another cloud. That's awesome if that is a focus point. Serverless, definitely, I would argue, developers can focus on the business logic. So the SAM, CLI, gives you quite a lot of leverage, and you can more or less focus on the business logic, really. And for both of the containers and serverless solutions accounted, and the ratio of code versus YAML is pretty much the same, so you will have to deal with YAML one way or the other. Sorry for that. Definitely increases development velocity, so you get stuff faster out there. Depending on how fine granular you do, the microservices could end up pretty much the same. The not so great, in terms of Kubernetes, can be a bit of a pain point handling the container images, especially if you think about the overall development cycle. So imagine every time you change something in one of the services, you have to build a new image, you have to push it to a registry, Kubernetes needs to pull it and deploy it again. Again, as I said, there are certain tools that allow you to shortcut certain of these phases, but that turns out to be, for many people, many organizations, quite challenging. And the core DX of Kubernetes is rather poor. It's not really a nice way for a developer to get into that. You really need to get the tooling right to make that not so painful. Serverless, you can have language-dependent latencies. So obviously, JVM has other cold start characteristics as Python, for example. And state hydration. So that's probably one of the most challenging things. Imagine your serverless function, your Lambda function, has some dependency. It needs to pull some state from whatever, some database out there, whatever. And before it doesn't have that state, it can't do its work, right? And that is what is referred to state hydration. And because it is stateless, you do have to do that every time. Doesn't matter how warm that function is, if everything is already there, you will need that, or you will run into that issue. All right, the rest is just a couple of resources in articles and a few books that I can recommend that you can read there. And I think we have enough time for Q&A, and that was actually my main goal, because I wanted to, because everything else is there, right? You can go to that repo and try it out yourself. Should be rather well documented. Just have a look at that repo. Slides are up as well on the website. So I'd like to hear from you. Where are you? Do you have a boss that comes up to you and says, let's modernize it? Do you have any questions, any concerns? No one in that position. Nah, one over there. Should I?
I'll do it.
Yeah, awesome. I see more.
Who was that? Oh.
If you wanted to run absolutely everything, so your front end behind API gateway, how straightforward is like authorization and authentication and so on?
It was not the biggest problem. The biggest problem that I had was essentially passing the payload through the API gateway to the Lambda function, and that's where I ended up with the pre-signed URLs, because the ping and JPEG just didn't go through. So that's one thing I ran into. Everything else, that's just the normal IAM policy dance where you need to decide how to do things. But yeah, not that hard.
So when you have around, like, let me say 300 Lambda functions and they run and you change something, and how do you ensure that everything still runs? So what are the quality strategies?
That's an excellent question. It's one of the critique points I always have with Lambda, that unless, so either you have a handful of functions, right, or you're in a bad place. If you have a lot of functions, you need some kind of orchestration, effectively, that allows you to look all over that. There are certain projects. I know that IBM came up with a project. I think there's something at AWS as well. But many functions. So if you take an existing monolith and you end up with, let's say, 300, 400, whatever Lambda functions, you're probably ending up in a place where you need to write that kind of orchestrator yourself, right? To figure out what is going on, what is up, what is new, whatever. Yeah, definitely not the best place. Any more questions? Yes. I'm just going to throw that in there. You catch, right?
Thanks. A very nice talk. Thank you. Just a question. What do you think about hybrid architectures where Kubernetes will be served as a long-term, like main application controller, and functions will be used only for heavy stuff, like not to rent lots of big machines, so it could be probably more efficient?
So if I got the question right, it's like this hybrid setup where you assume, but let's put it the other way. If you do have a Kubernetes cluster already, if you're subscribed to that, then it's perfectly possible, and you probably should, be using things like OpenFast, there's OpenWhisk, there are many kubeless, there are many options that you can run as frameworks on top of Kubernetes, if you have already subscribed to the idea of Kubernetes, right? Again, the main point of Kubernetes being that portability, so you're not, more or less, not locked into a certain vendor's API. If portability is not that big of an issue, so that's where you have to somehow draw the line or see what works for you best. But definitely what you described as this bang or whatever you used, yes, I subscribe to that idea that if you are already committed to Kubernetes, if you have Kubernetes as the base platform, using serverless platforms on top of that, anything from Knative up to, as I said, OpenWhisk or whatever, definitely a great way to go. Not saying that everything is already very mature there, definitely not compared to Lambda, but it's getting there. Any more questions? Yes.
For the serverless, how about the testing? How do you, what are your approaches on that?
So that was probably the biggest pain point. So initially I was like, oh, God, cool. SAM allows me to do that locally, right? Until I figured out actually all that works is the HTTP API gateway and the Lambda itself. So any kind of state, I had to go online, which means I ended up doing everything online, right? So essentially change something, and that's what the make actually does, right? Uploads it to a S3 bucket, kicks it off, deploys it, and it's there. In average, maybe once it's up, the initial CloudFormation deployment takes a few minutes, but once it's up, a matter of 10, 15 seconds until you have the new version there. It's not that bad. Unless you have, huge dependencies and you're pumping up, 500 megabytes every time. But you end up, that's why I said, it's very limited. I'm not saying that this might not change. SAM might become more powerful. SAM is essentially just using locally Docker to emulate that API that it has there. But again, it only gives you the HTTP API gateway and the Lambda function. Everything else you need to go online. Yes?
What about serverless containers? So like Fargate, which is kind of like a manager environment for containers, deploying containers, is it like trying to achieve the same abstraction layer the Kubernetes is trying to do, but in a providing more of like a more managed environment?
Excellent question, and I wouldn't have expected anything else from Jana, obviously. So for the people who don't know what Fargate is, essentially think of it as you already called it serverless container, whatever. You don't need to manage a Kubernetes cluster, whatever. You just say, here is my container image, whatever, and here, run that task, it's long running or whatever. I find it great in the sense that, all that management overhead goes away. I think we still have to see, and then you get up and running extremely quick. The challenge that I see is twofold. On the one hand, mentioned already the main point of Kubernetes being this portable system that you can move between different environments. Can you do Fargate, I don't know, in your on-premise environment and then move to the cloud? And the other thing, as I said, in terms of extending it, if you have the need, Kubernetes provides you with a wonderful extension mechanism called custom resources that allow you to essentially do any kind of workload, extend Kubernetes in a sense that it understands your workload. You might not have the same possibilities there with Fargate. These would be the kind of limitations. Otherwise, I would say absolutely limitations. These are the current things that I don't really have a good answer to. But otherwise, yeah, absolutely. No doubt. Any more questions? We have 2 minutes. Okay.
What's your opinion about versioning of serverless Lambda functions, something like that? Because when I have APIs and I have versions, then I become trouble. And if I have even smaller functions like serverless Lambda functions, the trouble gets even bigger, I guess, if I introduce versioning.
That's kind of like implicitly done. So every time you deploy a new function, you get essentially a new zip file or whatever in there. That's automatically done for you. I'm not entirely sure if you can actually go back that easily. I've never done that. But yeah, it's automatically done. So you don't really have to care about that in case of Lambda. I'm not sure. I've never tried that. Sorry? Oh, sorry. The question was, can you use 2 different versions of a function at the same time? And I said, I haven't tried it out. Might be the case. I'm not sure. All right. Cool. Thank you.